Okay, so homework questions from 12.8. So the first one that was asked here is number 4, and it's a true-false question. And I'll just write it up like this. So, if f of x equals x over 1 minus x, and the absolute value of a is less than 1, then f prime of a is the limit as n goes to infinity of the sum from k equals 0 to n of k a sub k, right? And so the question is, it's just a true-false question, so is that true? And so this is a little bit different than anything, or the way it's worded is different than anything we've really looked at before. Let me point out, what is this, the limit as n goes to infinity, the sum from 0 to n, k a sub k. That's just means, right, that you can just go off to infinity, right? It's just saying take the limit of the partial sum. So it's the definition of the sum from 0 to infinity of n, a to the n. Does that make sense? So we're just trying to see if the derivative equals that, okay? So all we do is we think, here's f of x, right? It's x over 1 minus x, which is x times 1 over 1 minus x, and we have a series for 1 over 1 minus x, right? Which is just the regular geometric series. So this is x times the sum from n equals 0 to infinity of
X to the n.
just x to the n. Okay. Does that make sense? And what happens if we pull an extra x in then? What do we end up with? The sum from 0 to infinity x to the
N plus 1.
n plus 1. Okay. And let's see. I guess this is okay. So you can view this in a bunch of different ways. Let's do it like this. This is what? When n is 0, what's your first term? X, then x squared, x cubed, x to the 4th, and so on, right? So what is f prime then? Well, on one hand, it's the derivative of this, right? You can do term by term. And again, this is only true if the absolute value of x is less than 1. That's why there's this condition about the absolute value of a being less than 1. But now we should be able to take our derivative term by term, and so n plus 1, right? X to the n. Is that okay? No, for integration you get a plus c, right? We're differentiating.
Oh.
Is that okay? All right. So now, what does this look like? Or maybe what does it look like here? If I do derivative here, I get 1, right? Plus 2x plus
3x squared,
3x squared plus
4x to the 3rd.
4x cubed and so on, right? And so now the question is that the same as this? No, right? The powers aren't matching up, right? It's the coefficient is 1 bigger than the power in our derivative over here, right? And so so once you plug in a, you get the wrong statement there. Does that make sense? And so this is okay. Any other questions on that one? All right. So 17. So this time it says use differentiation of a geometric series as appropriate to find a power series representation for the function. And so here's the function f of x equals x squared over 1 minus x squared. And so you're supposed to find a power series for that using, well, it says integration or differentiation, right? Or just says use differentiation. But in general, you can integrate or you can differentiate our basic, right, series for for 1 over 1 minus x, right, for the geometric series. So we're going to manipulate that. And so before we actually do any work, we know this series. As we just said on the last one, right? And then we know the derivatives of this. What's the derivative of 1 over 1 minus x?
1 over 1 minus x.
And
It's just that, right? And what's the derivative on the right-hand side? So this is, differentiate, we get this on the left, on the right,
M
oh, from 1, right? And
x.
oh, put it equal then. And x to the n then. There we go. Is that right? Okay. So the series that we're after is pretty close to that, right? It's just got an x squared up top. And so all we have to do is say our series f of x, which is x squared over 1 minus x squared, is just x squared times that. Oops. So we just pull in that x squared, right? And then we'll get what power of x now?
X to the n plus 1.
The n plus 1, right? You add 2 to that power. That make sense? Just 2 plus n plus minus 1 is, oh, I said plus 1 and I wrote plus 2. Plus 1. Is that okay?
I wonder, can I just put the square out?
Okay, so let's talk
So-
about that.
Just because I use the other way.
No, so that's a good thing to notice. So let's look at that. So I would say this is the correct way to do it, or the best way to do it, right? X is between -1 and 1, or in that interval. I think I was using the interval last time, but again, that thing works there. So you're saying if I see this x squared over 1 minus x squared, that maybe I can view it as this? Is that what you're saying?
Yep.
Okay, so that's okay. Let's look at the inside here for a second. So it's x, 1 over 1 minus x, right? And then we're going to square that whole thing. So, well, let me just write it this way. It's x times this, right? Okay, so you get that, right? Now that's not a series yet though, right? It's two things multiplied by each other. So this is really this series x plus x squared plus x cubed plus x to the 4th plus x to the 5th, right? Times the same thing. And we're going to actually do a little bit of this in the next section. But how do you multiply two infinite series together like this? Because you want to end up with a final series, right?
increase the power by 1.
Well, it's more than that though, right? Because what you really get is this thing distributes through this whole thing. You get x times all of this, right? So you'll get x times x gives you x squared, right? And then you'll get x times x squared will give you an x cubed, x to the 4th, and so on. That's just the x times all of that. Plus you'll get x squared times all of that, so you'll get an x cubed, x to the 4th, x to the 5th, right? Plus you'll get x cubed times all of that, which will give you an x to the 4th, and so on. And so the point is that you can think of doing this, but it's hard to come up with a closed form of how many x's do I have? Well, I only have one x squared. I get an x cubed here and here, so I get 2x cubed, that's fine. But then how many x to the 4ths do I have? How many x to the 5ths? If you could figure it out in your head, it'd be fine, but you need a closed form in the end, and I don't think it's obvious where it comes from. Now, if you think about it for a little bit and you know much about like binomial coefficients, you can come up with the formula, but it's definitely much messier to do than to follow this time. Does that make sense? And in particular, right, like here, if we write this out, when n is 1, we get 1 x squared, right? When n is 2, we get 2x cubes, we get 3x to the 4th, 4x to the 5th. So you might be able to recognize that pattern if you start multiplying that out, but it's definitely not as obvious. All right, other questions?